Hey, we're back. At the end of the last video, we were discussing what we could try and do to fix our clearance issue right here. And if you recall, one of the things that I had thought about doing was narrowing up this gap between the two polycarb side pieces of the intake. So what you see here is the end result of some stuff that I marched down that path to do. And then it hit me. I can't narrow this up. I need to maintain 1 inch from this surface to this surface in order to be able to put any sort of aluminum structure back here. So I need to maintain that 1 inch, which is what these spacers are. So what you'll see, you can see, well, there we go. Let me select that. So what you see here is I had already gone through and taken a 1/4 inch out on both sides. Those spacers are, instead of being 1 inch, or 3/4 of an inch. And it ain't gonna work. So what I'm gonna do is I'm gonna show you how to revert a change, how to go back an entire version in the intake. We're gonna do that. And then what I'm gonna also do, I think the rest of this video, what I'm probably gonna do, and you gotta think about it in terms of like getting stuff kicked off for fabrication. I wanna get the polycarb like done, so that like if this was a real event, a real time crunch we were under, we could get this stuff done and get it off to either a sponsor to help us cut the polycarb on a CNC laser cut or whatever. So that's going to be the focus of the video today. So first things first, let's go ahead and undo my work I did. So if you recall, this was the version that we were working with. It was updated intake X2. So this latest version is version 6. That's the one that's reflected in the drawing with the spacers that are all wrong. So what I'm going to do here, this is version 5. I've already gone through and checked, and it doesn't have any of that spacing removed or anything like that. So what I'm going to do is open that. So you can see here, so this is version 5. We'll double check. Oh, see, that's 3/4 of an inch. So I need to go back another version. So let's go back to version, this is version 4. Let's try opening that one up. All right. That's got these spacers. So it doesn't look awful. We might be able to work with this one. It looks like the only thing is the spacers need to be fixed. So what I'm going to do is I'm going to go ahead and do that by zooming in on one of these spacers. And if you recall the last video, well, maybe it wasn't in the video, but we just pulled that surface. So 0.25 there. I do it to 1, and they're all good. And then let's check our spacing from surface to surface. There to there. 1 inch. So we're good there. All right, so now we've kind of reverted back. So what you have to do is you have to come up here, File, Save as Latest. So what this will do is, even though we were making an edit on version 4, if I do Save as Latest, it's going to make this should make this a version 7. And it gives you a warning. It says, hey, do you want to overwrite this? And you say yes. And then we'll just click save. There we go. So now you'll see it says version 7 up there. And then if we go back into this, into our main design, we'll check our references, we'll reload it. Yep, you can see my the hex shaft is now the right dimension. So we should be good to go. So we've undone that. So now the only thing we really have to figure out is what we're going to do with the drive wheels. And again, because this is kind of live and on the fly, I got to figure that out. So I'm going to pause, think about it for a few, and come back. Okay, so I think what we are going to do is we're going to add another motor up here. We'll probably, like, if this was a real thing, we'd probably revert this to like a Neo 550. It's showing a sim motor on there. Overkill for what you need. A 550 over there. And what we're going to do, I made the call. We're just going to add another motor here and belt out straight through this. We might have to move some of these standoffs a little bit to make the belting work. Or not, we'll see. But what I wanted to go into now is how to do the belt calculations. So as an example, what I'm going to do is come over to this other side. So this motor and belt setup we haven't touched from the EveryBot the EveryBot design. So what I'm going to come over here and show you is how to go about designing a belted system. So the thing you got to keep in mind is the belts are pre-made and they come in specified lengths. So what you have to do is that's a constraint as far as your designs go. So you have to take that into consideration. So what I'm going to do here is I'm going to show you. Okay, and it uses center to center. The belt length is use center to center, and then the pulley diameters. So what I'm going to do here is show you how they went about designing this. So I'm going to measure just center to center of this first setup. So to do that, I got the inspect or the measure command going. What I did here is I turned on snap points. So what that'll enable me to do is I'll hover over the surface. And if you look over the motor mount, you can see all these snap points I can snap to in order to pick whatever I want. And you can see in the text, hopefully, hold control to lock snap points. So what you do is if you press and hold control, it'll keep those snap points open. No matter where I go with this mouse, it'll keep those snap points open. So the first thing I want to do is I want to pick the center of that hole. So right there, you can see that it's maintained the center point of that hole on this surface. Now the same thing I want to do here is pick the center point down here. Okay, you can see it hovering over right there. Okay. The other thing I did is I turned on alternate units. I'm a millimeters person. That's the way I think. You might be inches, doesn't matter. So you can see here, it's a little over 3.5 inches, a fraction, and then just about 90 millimeters. So what I'm going to do now is bring over the West Coast belt calculator. You can see I was messing around with the EveryBot. So that measurement we made was 89 millimeters, 90 millimeters, we'll call it. So we'll come back over. So the first thing you do, well, the way this works is you input your pulley dimensions. So I measured the pulleys that came in the design, and they were 24 tooth. So 24 on both sides, and then it calculates the pitch diameter. The other thing you need to do, make sure you do, with most of the pulleys you're going to be working with in belt setups, it's going to be a 5 millimeter pitch. So change that. It defaults to 3. So we got our pulley dimension. It calculates the pitch diameter for us. So this one, we measured it to be 90 millimeters. So I input 90 millimeters in the field, and then it automatically calculates what the perfect belt, so that's desired belt, that's what the belt needs to be, and that's a 60 tooth, and you can see here it's exactly 90 millimeters. So based on the inputs I gave it, it said a 60 tooth belt is perfect for our application. So if I come back to the drawing, escape out of the measurement. So that is actually that part. Find in browser 0617. I don't know if this is going to look up. Again, this is live. ACP 0617. And then where's 06? There it is right there. It's a 60 tooth belt. So that's how you go about calculating. So you have to kind of consider your design. So now, because we're making the call here to go from here, from this hole, all the way down to here, we got to see what dimension that is, and if there's a belt that'll be good for our application, or if we might need to do a little bit of tweaking. Spoiler alert, we will. So let's measure the same thing on this side, but we'll go down from here, from our main, again, our motor mount hole, down to this hole. And you can see 306.1 millimeters. So let's come back to our belt calculator. And go back here. There we go. So we wanted 306 millimeters. So let's put it was 306.1. Let's be precise. And that's got to be it. So okay. 12 inches. What just happened here? Units, millimeters. Let's just refresh the entire page. All right, so 24. We want it in millimeters. 5 millimeter pitch. 306.1. Hit enter. Okay. Here's a problem. Okay. If you look here, the desired belt is 145 tooth, but it's shorter than our 306 by about 4 millimeters. That ain't gonna work. It would be really, really hard, almost impossible to get the belt on. You'd be fighting the belt tension. They don't make belt stretchers. They do make bolt stretchers though. So then we look at the next off-the-shelf belt. That's 150 tooth. It's too long by a solid 9 millimeters. So what do we do? Okay. If you recall, one second. So if you recall, we had a clearance problem here. We were trying to get shorter, right? So what we can possibly do, if we go back to our intake brainstorming, what we can possibly do in order to get the in order to get a little bit more clearance here, we'd make a trade-off in the spacing of these rollers. A 4 millimeter trade-off. I don't think that's the end of the world. The other thing we could possibly do is if during, and this is something that would come out during your testing phases and your prototyping, and when you get it all together and you're trying to get the thing going. What a lot of teams did is instead of these compliant wheels up here, they went with smaller diameter, like almost solid tubing. I'm not sure. We didn't use that on our robot this year. I don't know what the benefit of that was. It's a little bit, probably a little bit lighter. But what we could do, what you could possibly do is, even though we're going a little bit narrower, again, it's only 4 millimeters. We could play around with the compliant wheel setup here to try and make it a little bit, even if it comes out being too snug, we can fix it afterwards. So I'm of the opinion, in order to get that belt to work right, we move this thing towards the motor 4 millimeters. Let me double check. So we were at 306.1, 302.5. Let's pull up calculator, check our math. 306.1 minus 302.5, 3.5 millimeters. That's easy. Okay, so let's go about doing that. So what we're going to do, well, first things first, we don't need the gear. We're not doing the gear anymore, so we'll delete that. Okay, so what I'm going to do is I'm going to do a top view, and I'm going to select all those, and then show hide. There. All right. So I turned all that stuff off. Oops. All right. So what I'm going to do now is, because I need to move it in a straight line closer to that motor mount. Easiest way to do it is, well, actually, you know what? We're going to do it this way. So first things first, I'm going to hit the M for the move command. I'm going to do a face, and I'm going to select that face, but then I'm going to set my pivot, and it doesn't want to work. All right, and then we're going to, oops. So what I did is I grabbed that angular handle and kind of dragged it so that I'm at that point, at the center line of the motor mount. Okay, so once my hand is over the center point, again, this doesn't have to really be perfect. I'm trying to get as close as possible. Once my hand's over the center point, I'm going to release it. But you can see now that it's, when I do this, if I click on that and I do 3.6 millimeters, it was 3.6 millimeters, let's call it. Let's just do it 4. Let's just be safe and do 4. 4 millimeters. And hit OK. There we go. Okay, so now all of those holes have been moved in. Because remember, we're working on one part, 4 instances. Now the other thing I want to do is, hey, I just bought myself 4 millimeters of clearance here. Let's press and pull that surface in. Let's just do like 3 millimeters. Oops. Oops, that's not going to work. Escape. Press and pull. Okay, so it's got inches in there. Okay, so 1.063, let's call it 1.125. See what happens. Might be a little bit smaller. Too small. We'll try 1.1. Okay, so we just moved this hole. Let's double check and remeasure everything. So that hole, and again, remember I'm clicking on my snap points, I'm holding control. 302.153. Perfect. So 145 tooth belt gives us about a 1/2 mil of extra, which should be just perfect. I don't think this isn't really a high torque application. We're not really worried about belt slipping too much. So we're good with that. Okay, so now we have to find those parts again. And we got to move that whole front axle the same 4 millimeters. So what we're going to do, okay, it took me a second, but I wanted to figure out how to show all that whole front axle without going through and clicking the hidden stuff. So you just come up here to your main, like the top of the tree, and then show all components. And there we go. So now the next thing we got to do is move the axle. Remember, we moved it 4 millimeters, moved those holes 4 millimeters. We got to make the axle line up. What we're going to do, we're going to come down here. We selected all those parts. And then let's do that. Now we're going to move, and we got components. So now we're going to do a point-to-point move. I want to make sure that the center line, that radius of that bearing matches up with the radius of that hole. So here we're going to do a point-to-point. So now, got to make sure, so that edge lines up with that edge. And not exactly right. You can see here from the front. See how it's kind of buried down in the polycarb, so that ain't exactly right. So let's repick our points. So let's pick our origin point again. So now let's try that one. There, that should work. To there. Check how it looks from the front. Oops. That looks much better. So we're okay side to side. And it looks like we're okay in this plane, so we're going to click on OK. Okay, so we've got the hole moved. So now this is going to be the part where we have to figure out, do we need to move these standoffs and fasteners? And heck, we might even want to add some. I don't know if we'll add them in CAD. That might be one of those things where you get it all together and it's a little too squishy. So you can just drill and do some more standoffs after the fact. So let's go ahead and select that. We will show hide. Okay, so this is what it looks like from the side without the side panel on. So the first thing is we have to move this pulley over to this rope, over to this shaft. So that shouldn't be too big of a problem. So we'll just select it. And again, we can do another point-to-point move. So let's select the origin point. We'll just select the center line of that hex. And then the center line of that hex. That looks good. Okay, so probably move that spacer as well. There. There. Pretty good. Again, we're not quite sure what all we'll need. I think there might have been some spacers in here that I deleted from the first attempt. That looks okay. Still do need that bearing. So now let's look at it from the side and see what our motor setup looks like. It's looking like this one at least is going to have to move. Yeah. Okay, not a problem. Let's save our work. And then to make things easy on ourselves, we'll just copy that motor from the other side. So the first thing is to make it look like it does over here. There are no spacers there. So we'll blow away those spacers because we don't need them. Delete, 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 delete. There, okay. So then what we have to do is copy that motor setup. So we're gonna do exactly the same way we did the front axle. I'm gonna drag a box all the way over here. And then I'm gonna move, but this time I'm gonna create a copy. I'm gonna click this checkbox. Okay, so again, we can do another point-to-point move. This is gonna be kind of like a two-step point-to-point move, and I'll show you. So first things first, I wanna click the center line of this hole, there. And then we're gonna move it. We'll fix those washers in a minute. So then I want to move it over here. Well, that ain't right so far, because if you recall, we're missing the other bit of polycarb over here. So what we got to do now is a free move. So we're going to select the origin over here, but we got to rotate it 180 degrees. All right, so that's so far okay, but we now have to scooch it over towards the outside. So again, we'll do another point-to-point move. And what we'll do this time, select the center of that. And then the center of this. Now that looks right. You can see our bolt head is correct side to side. Now the bolt holes may not line up. I'm not concerned about that. If you really wanted to, you could rotate this whole motor about the axis. I'm more concerned about, do I have the right thing side to side? Do I have the thing correct side to side? And lined up with the hole. There we go. All right, so now that that's done, now we can really figure out what exactly we have to move, what is going to be in our way. Now to do that, what I'm going to do is I'm just going to create a sketch on the one piece of polycarb. So I'm going to project that, and then I'm going to project that outer diameter and that outer diameter, and then click on OK. Okay, so now what I can do is I can draw a line from here to here, and then what I'm going to do is I'm going to offset that line. And again, this doesn't really have to be super precise. We're just trying to get an idea of the path the belt is going to be taking. And we'll do that, and then we'll offset it again the other way, 0.74. Okay. Okay. So this is roughly the path the belt's going to take. So you can see here, this is awfully close. That hole, that spacer right there is awfully close to where our belt's going to be. So I'm really wanting to move that hole. That's not a big deal. We can just bring it down a ½ inch and it'd be completely out of our way. Another thing you could possibly even consider doing is you could almost turn this into a belt tensioner or an idler roller. Like if you brought this down and added a bearing setup around that, you could turn that into kind of like an idler roller, so you keep tension at least on one side of the belt. It's ideal to keep tension on both sides, but again, the belt size is almost perfect for us, so we're not going to worry about that. Okay, so we do have to move that. We'll just move it down about a ½ inch. All right, so the first thing we're going to do is we'll show hide that, show hide that, we'll show hide that, and we'll show hide. Okay. So now we just want to move that face of that hole down roughly a ½ inch. So I'm going to move, and again, and now it's on faces. So that we got to make it into a free move, but we want to go straight down. You can see the axis was kind of funky the way it defaulted. So let's come here. Let's do like that. And then we'll move it 1, 2, 4. So a ½ inch down. Okay. Now it should have carried over to the other sides. Sure looks like it did. All right. So now we have to, those bolts we have to move. So come back up here. Show all components. All right. So we'll do that. And to select multiple components, I'm just hitting the control key and just clicking. I think there's probably another washer over here. Yeah. And the spacer. We'll move those. Again, we want to do a free move. We're onto the right side. And then we have to set our pivot. Again, accept our pivot. Do that. 4, 5. And hit OK. Now, that's good for that one, but the other side did not move. Which is okay. We'll grab it. We'll do the same thing over on this side. So that. Spacer and the washer. Move it. On the left side, let's check our pivot. Do that. Minus, oh, not minus, just 0.5. Okay. Let's get rid of those washers I forgot about. Nope. There. There. And then there. There. Okay. Turn that sketch off because we don't need it anymore. That's pretty darn good. So now we've got 2 motors. We'd probably go with a, again, like a small Neo. I think they're Neo 550s. Instead of the sim, we don't have to really update that for our purposes. Again, we're trying to get this thing designed so that we can go ahead and get these polycarb panels fabricated. So I think at this stage of the game, The polycarb is pretty much done. The only question would be if we wanted to make any changes back here as far as the mounting. So if you recall, the original Thrifty Bot setup had 1x1 tubing going down here. What we're going to do is, because we need a pivot in there, we need to make that 1x2. So is this adequate? It's more than adequate in terms of a pivot and a bearing surface, like bearing mounting. But what we would be having to do here is sandwich this polycarb between the bearing flange and the aluminum. You could possibly open up this hole so that the flange sits in beneath it, but I think that would be okay. And again, we're going to have clamp collars all over the place, so it's not like it's going to like you're going to have the polycarb slapping against the surface of the aluminum. But for the most part, and then the other thing we could possibly do is, because this is 1x2, we could add some rivet holes up here, because it's going to come in this way. We could add some more rivet holes in there to help secure it, or if we wanted to, we could like make them through bolts. You don't want to worry. You don't want to do too much through bolting with the aluminum unless you put a crush spacer inside the tubing, which is kind of more trouble than just riveting itself. So I think for now we're pretty much done. So let's finish up, and then we'll come back in and check our updates. So everything got updated, showing our other motor. It's showing the pulley on the wrong side. Did we move the pulley? Okay, so what you just saw is a lovely feature in Fusion where sometimes it doesn't capture some updates and linked parts in an assembly. I don't know why it does it, but we were wondering, where the heck did my pulley go? I know for a fact we had moved it from this shaft to this shaft, and it didn't take. I don't know why. Unfortunately, the only way around it is to actually delete the link and drag it back in. So that's what you didn't see here was me doing that. So what you can see now, we were checking to see clearance. It's a little bit better. It's oh so close. But it's not the end of the world. I don't even know if we'll end up having to go down that far. Because the other thing we can do, and this is probably what we'll do, because essentially the intake is essentially done. So I think the next video is what we're going to start getting into is the pivot point. What do we do? How do we go about putting a big old axle through here and go about with the pivot setup? I got some ideas on it. We might end up having to push it a little bit further forward, which would solve this problem here. It would enable us to get this rotated down here. I'll move, rotate. Let's select the axis. It would enable us to get this thing down right about there, which is very, very close to a 45 degree, which would be kind of cool to have, because I mean, that would be the most forgiving in terms of bopping cubes out of the launcher, or out of the thing and into the scoring receptacles. But the trade-off, if we end up wanting to go down that low, we don't have a whole lot of real estate down here for stuff like, oh, a battery, the Robo Rio, the radio, all that sort of stuff. So what we might end up having to do is limit our travel to something more like that, and go from there. It's not ideal, but I mean, if you look at it, it's not too bad. We would just have to juice the motors up during a launch to make the arc, the parabolic motion, ensure we can hit all those, and that could be a gearing thing, that sort of thing. But I do want to try and keep this pivot point. I don't want to deviate too much up down. We might go up just a smidge, but then we had designed this so that when this whole intake was mostly flat, we still had pretty good engagement. And the other thing we wanted to try and do with it was we wouldn't put that on too much of a brake, so that the intake, as it was going up and over a cube, it would have a little bit of forgiveness in there, so that it didn't just snowplow the cubes away. So right now the polycarb is done. That was kind of the goal for the video. Next video, we'll get into designing the pivot.